This is the Algebra 3 practice test for Module 1. So let's get right to it. All right, I'm going to work this whole practice test to help you out. If you are stuck anywhere, you can kind of see what I did on these same problems and hopefully clear up any confusion you have. All right, number 1 says, given the equation negative 4x plus 10 equals 2, which order of operations completely solves for x? Well, what do you do first when you have that? First thing you're going to do is move the 10, right? And after you move the 10 to the other side, that would leave the negative 4x. We would divide by the negative 4. So it says do that first. Right here, this is the one. First thing it does is subtract 10. Right? That's the correct order of operations. And then divide by the negative 4. Don't let those trip you up. You've known that for years and years. See, Kisha and Ray are asked to solve negative 5x minus 14 equals 2x plus 7. Identify where one of them made an error. Okay, so they both start with the same problem. Kisha decides to subtract 2x from both sides. So she's moving this 2x to the other side, subtracting 2x. So that's fine. What did Ray do? Ray is adding 5x to both sides. So she's moving that 5x. That's fine. You can do it either way. You can move the x's to the left or you can move the x's to the right. There's no problem there. So after they do that, they're left with negative 7x over here, because combining the negative 5 and negative 2 is negative 7. Minus 14 equals 7. This one, we just have the 14 over here. Negative 14 equals 5 plus 2, 7x plus 7. So we're okay right now at that step for both of them. Then with right there, it's just need to move the 14 to the other side, right? So adds 14. That looks good. Move the 14 to the other side. On this one, you need to move that 7 to the other side, right? So you need to, oh, looky there. If you have a plus 7, you got to subtract 7 from each side. There's our mistake right there. She made the error when she added 7 right there. Ray made the error when she added 7. Should have subtracted. So there was the error we were looking for. All right, let's look at number 3. So given the equation 4x minus 26 equals 2x minus 4, another order of operations. Which one would do that? So the first thing you do, well, you could move the x's or move the constants first. So it looks like you're going to move the x's. That's fine. So you can either subtract 2x or subtract 4x. So let's see. So if we subtract 2x and move that over there, and then add the 26 to move that over there, this will leave 2x when we subtract 2x over here and divide by 2. That looks like that would work. What does this do? Subtract 4x, which will make this a negative 2. Add 26. Oh, that's going to move the 4 and the 26 to that side. It'll leave nothing over here. That's not right. Subtract 4x, move it over there. No, you can't subtract 4. You'd have to add the 4. And that's to subtract the 4. So yeah, that first one is correct. That's the only one that works. That you're moving the 2x and then add the 26 to the other side and then dividing by the 2 that's left with if you move the 2x. Okay, so Jack earns $50 for washing cars on the weekends. Okay, so $50 per car. All right. Or he makes $50 total. He earns $50 for washing cars. So that's total. He makes an average of $4.25 in tips Write the function of his earnings and solve for how much he would make after 6 hours. So let's see. He makes that per hour. Plus he makes about $50. So he makes $50 total. Plus he makes another 4.25 per hour. So let's see. This says 4.25 times X plus 50. Well, if this is per hour, 425 times the number of hours, right? This looks right. We'll check this 5425. 50x, so 50, no, that wouldn't be per hour. But per hour is going to give us a variable, right? We're going to need to put an X for per. So he doesn't get $50 an hour, $50 an hour. Those are both wrong. This makes $4.25 an hour, plus the $50 he makes for washing cars. So which one of these is right? So we got to figure out. Both these equations are the same. So after 6 hours. So let's see. 4.25 for 6 hours plus the $50 that he makes. Right? So 4.25 times 6 is 25.50 plus $50. So that's going to equal 75.50. So this is the one that's correct. That's the correct equation, and that is the amount that he will make after 6 hours. So once we figure out these are exactly the same equation, we just substitute the 6 in for the X, the number of hours, and figure out how much money that Jack will earn. Okay. Given that f of x equals 2x plus 1, so that is our f of x. 2x plus 1, and our g of x is negative 5x plus 2. What is f of g of x when x equals 3? So if x equals 3, let's put that in for the g first. Negative 5 times 3 plus 2. So negative 5 times 3 is negative 15 plus 2. So that'd be negative 13. So g of 3 is negative 13. So what is f of negative 13 then? 2 times negative 13 plus 1. So 2 times negative 13 is negative 26 plus 1 equals negative 25. So that's it right there. So f of g of 3. Because we said x equals 3, so we can substitute x in there. So f of g of 3. So when g of 3 is negative 13, and then we take the f of negative 13, get negative 25. Let's move on. Okay, number 6. Okay, now this is f of x, and this is g of x, and we got to do f of g of x when x equals 2. So the inside one is g of x, so let's make that g of 2 and solve that. 2 plus 4 divided by 3. All right, we just substitute that 2 in for the x right there and solve that. 2 plus 4 is 6 divided by 3, and 6 divided by 3 is 2. 6/3 is 2. So then we substitute that into f. F of 2 equals 2 squared plus 2 times 2 plus 3. Well, 2 squared is 4, and 2 times 2 is 4 plus 3. So that's going to equal 11. All right, it's just knowing where to substitute. The rest of it's pretty simple math. So start on the inside out. Substitute the 2 into the inside function, and then whatever the result of that is goes in the outside function. The function for the cost of materials to make a muffin is f of x equals 3/4 x plus 3, where x is the number of muffins. So, okay, so x is muffins. The function for the selling price, all right, selling price, is g of f of x, where g of x equals 3x plus 4. Find the selling price of 20 muffins. Well, we said x is the number of muffins. So g of f of x, so f is on the inside, so we need to say f of 20 equals 3/4 times 20 plus 3. So what is 3/4 times 20? Well, if you're not comfortable with fractions, there's a few ways to do that, but you can make it 20 over 1. 3 times 20 is 60 divided by 4. 60 over 4 is 15. 60 divided by 4. So you can also convert that to make it 0.75 because the 3/4 is the same as 0.75 because 3 divided by 4 is 0.75 times 20. And you'll also come up with this 15. So this equals 15 plus 3. So that equals 18. So f of 20 equals 18. So now we need to make this an 18. So g of 18. So g is 3 times 18 plus 4. 3 times 18 is 54 plus 4. So 58 is the answer we are looking for. 58. All right. Remember, anytime if you need to go back and pause this or rewind that and look at the again, or if you don't understand, please email me, get with me, come to class, or we'll set up a time and make sure that you understand this. But we'll move on. All right. Given the function f of x equals 5x minus 3 over 4, which of the below expressions is correct? So this is the inverse. Remember that little -1 up there is not saying take it to the power of -1. That is the inverse function. That's how we designate that. So the inverse function of x. So to find out the inverse of this, we change the f of x to a y. We just rewrite it as a y instead of in function notation. 5x minus 3 over 4. And then we have to swap the x and the y. So we'll make it x equals 5y minus 3 divided by 4. We just took them traded places. So you can see the x moved from over there to over there. The y took the x's place. Then we solve this to make it y equals, just like that was. So the first thing we do is multiply by 4. If we're dividing by 4, we multiply by 4. So 4x equals, and then we multiply this by 4, it goes away. Okay, so we've got 4x equals 5y minus 3. We're solving this for y, so let's move the 3. Plus 3. We can't combine those. Those are not like terms, so it just gets put on the end. And then we have to divide both sides by 5. So this is what y equals. Y equals 4x plus 3 over 5. So that is what the inverse of f of x is. 4x plus 3 over 5. Yep, so it's right there. There's our choice, 4x plus 3 over 5. Swap them and then solve it for y again. Just rearrange it till you get back to y equals. And that will get you back where you need to be. All right, let's go up to number 9. Given the function f of x equals 3 times x plus 2 minus 4, solve for the inverse function when x equals 2. So first we have to find the inverse function of this and then substitute the x equals 2. So let's rewrite this. Y equals 3 times x plus 2 minus 4. Swap places. X equals 3y plus 2 minus 4. And let's start solving this for y. So the first thing, let's order of operations, right? Parentheses first. X equals 3y plus 6, because we have to distribute the 3 to everything inside. Minus 4. X equals, we can simplify. Plus 6 minus 4 is just plus 2. All right, now subtract 2 from each side. I'm going to move it up here. X minus 2 equals 3y. All right, we subtract 2 from each side. That's what we end up with. If we want to divide by 3. So y equals x minus 2 divided by 3, which is also the same as the inverse function of x. All right, that's the inverse function of x equals y equals x minus 2. And then wants to solve it when x equals 2. So 2 minus 2 divided by 3, because we just substitute the 2 in for x. 2 minus 2 is 0. 0 divided by 3 is 0. So we're looking for that answer right there. 0 for the inverse function. All right. Which function below is the inverse of this? So y equals 2x plus 3 divided by 5. Trade places. Again, more practice. Trade places, the x's and y's. Solve this. So if it's dividing by 5, everything over here, we can multiply it by 5. So we got 5x equals 2y plus 3. Dividing by 5, multiplied by 5, cancel each other out. So we're just left with the 2y plus 3 minus 3. 5x minus 3 equals 2y. Divide by 2. Because those 2's cancel out. 5x minus 3 divided by 2. Right there. That's the one we're looking for. All right. Which function below is the inverse of this? F of x equals x squared minus 9. Okay, so y equals x squared minus 9. X equals y squared minus 9 plus 9. X plus 9 equals y squared. Oh, but we need just y, so the opposite inverse operation of squaring is the square root. So the square root of something squared is just what is underneath there, the y. So the square root of y squared is just y. And that is as simple as we can get. Square root of x plus 9 does not simplify. So the square root, though, does give us a plus or minus, right? If we take the square root of something. So our answer is plus or minus x plus 9, square root right there, square root of x plus 9. Yeah, don't forget when you take the square root of something, it's plus or minus. Okay, onward and downward. No, onward. On the graph of the equation, x minus 4, y equals negative 16, what's the value of the y-intercept? Well, if we had it in slope-intercept form, right, y equals mx plus b, the b would give us the y-intercept. So let's rearrange this to be y equals. So let's move the x to the other side, minus x. So we have negative 4y equals negative x minus 16. Almost got y by itself. Let's divide by negative 4. Got to divide everything by that. So negative 4 divided by negative 4 is just 1. So this is y. Negative x divided by 4 is negative x over 4 or 1/4 x. Because x over 4, that's just a 1x. So I have 1/4. My slope is negative 1/4. Negative 16 divided by a negative 4 is a positive 4. This is our y-intercept, positive 4. Because this is mx plus b. The m is negative 1/4. You may also see that written x over 4 plus 4. That's the same thing. That's the same thing. There's a 1 on top. We know that. When it's just x by itself, that means it's 1x. So that's the same as a 1/4, negative 1/4 slope. But it's just asking about the y-intercept. So if you're not understanding the slope, this is the important part for that problem. Okay, Brent was looking at his cell phone bill. He saw the total number of texts that he has sent is tracked. So in month 1, 120, month 2, almost doubled it, 237 every time. This is total. So yeah, he sent a bunch more texts the second time. So the function represented as texting per month is 117 per month, 117m plus 3. What does the 117 represent? 117 times m. Well, m is month. So this is the number of texts he sends each month. Each month. The number of additional texts per month, right there. Because that's the slope. Every month he's adding another 117 texts that he sent. He's very consistent. He must just text the same people, the same thing all the time. And 3 was just the starting out. He started out sending 3 texts the first day, I guess, and then every month, 117, 117, 117. Okay, a function is created to represent the miles per gallon that your car gets. what restrictions would be made to the domain? Okay, miles per gallon, miles per gallon. So miles per gallon, would it only include integers? Can you only have like 1 gallon, 2 gallons, 3 gallons, or can you have a half a gallon or 3/4? The domain will include positive integers. Now, again, that would be, you can't have a -1, -2, but this is saying, again, you can't have a half either, can't have a half a gallon. The domain would include all real numbers. Well, all real numbers would be all the negative numbers too. We're not going to have negative gallons. And the domain would only include positive numbers. Positive numbers, right? That means you can have a half. That's a number. That's a positive number. You can have 3/4. You can have a gallon and a half, but you can't have any negative numbers. That's what we're looking for, because it doesn't have to be just integers. You can put half a gallon of gas in your car. You can burn half a gallon of gas. You can have partial gallons. So it doesn't have to be just integers. It can be any number as long as it's positive. You're not going to have negative gallons of gas. All right. Number 15. A function is created to represent the amount of money that you save or spend each day of the week. It could be positive, it could be negative, right? What restrictions would be made to the range? All right, so days of the week would be your X. The range would be the Y, which is how much you save or spend. So would it only include integers again? Can you only spend like $1, $2, $3? Or can you spend $1.28, right? So integers. It would be all real numbers, because if you spend, it's going to be a negative number, negative 275. If you save, it's going to be a positive number, 270, right? So it can be all real numbers. All real numbers. Now, realistically, probably not all real numbers. You're not going to spend $4 billion. But I guess there may be some people that do, right? So all real numbers is the range, because it could be positive or negative in any direction. All right, to which graph does the point 2, 4 belong? Which one of these? Well, let's take that point, because that is the XY point, right? And let's substitute that in. So 4 is greater than or equal to 2 plus 3. Simplify that. Is 4 greater than or equal to 5? No, 4 is not greater than 5. How about this one? 4 is greater than or equal to -2 plus 8. So it's 4. Let's simplify that. Is 4 greater than or equal to 6? No, it's not greater than or equal to 6. How about here? 4 is greater than or equal to 4 times 2. Again, just substituting 2 and 4 in for X and Y. 4 and 2 minus 5. So it's 4 greater than or equal to 4 times 2 is 8 minus 5. So it's 4 greater than or equal to 3. Yes, 4 is greater than or equal to 3. We don't even have to check the last one. We can. 4 is greater than or equal to -2 times 2 is -4. -4 plus 9 is 5. So that's back to this statement. 4 is greater than 5. 4 is not greater than 5. So just substitute that in there. What is the equation of a horizontal line passing through the point 114? So if you have the graph and you have the point 1, and this is way up here at 14, right? 14. And then with the horizontal line that's going through there, up here at 14. Well, what does that graph look like? Y equals 1. Where does y equal 1? Y equals 1 down here. That would be this line when y equals 1. Y equals 14. That's it. Y equals 14. If x equals 1, that's all of these x's here. So that would be the vertical line. And that would also pass through that point, because this is the point 114. But that would be a vertical line, not a horizontal line. So that is the one you're looking for. Given the point 5, 6, and the slope of 5, Find y when x equals 21. Okay, so we need an equation. If we have this point and slope, we can use the point slope format, right? So it'll be y minus 6 equals 5x minus 5, right? Where we put the 5 and the 6 in the equation, because it's y minus whatever your y is times the slope and x minus whatever your x is. So we substitute the slope of 5, and the 6 goes where the y1 is, and the 5 goes where the x1 is. Now, if this was a negative 5, we'd have to change that to a positive because it'd be x minus a negative. So that would change signs. But these are both positive, so it looks just like that. All right. So when x equals 21, we can just substitute straight into this. Y minus 6 equals 5 times 21 minus 5. Right, so y minus 6 equals 5 times 21 minus 5 is 16. Y minus 6 equals 5 times 16 is 80. So we add 6. Y equals 86. There we go. That is one of our choices. Okay, number 19. What is the standard form equation of the line shown below? Well, when we have a line on a graph, we know we can go with the y equals mx plus b equation format. So what is our b first? Our b, it intercepts right there is where it crosses the y at -1. All right, that's a -1. So we know our b is -1. What is our slope? This goes, crosses through that point. We got several choices here. It crosses that point, it crosses through that point, it crosses that point, crosses that point. So we can pick any 2 points that crosses through and find the slope. So from here it goes down 2 over 1. And it's down 2 over 1. -2. -2 is our slope. Because it's rise over run. Our rise is -2. So rise over the run. The run is 1. -2 over 1. So if this is our slope and intercept, we can say y equals -2x minus 1. And then to put it in standard form, remember standard form is ax plus by equals c, where the x and y are on the same side and the constant is on the other side. So let's add 2x. So that makes this 2x plus y equals -1. That's the standard form. All we had to do is move the x over, and we go from slope intercept to standard. 2x plus y equals -1 right there. There it is. All right. What is the slope intercept form of the equation of the line that passes through 1, 3, and 3, 7? Okay, so we need the slope because we have to write this equation, and we always need the slope to start off with that. So what's the change in the y's over the x's? So if we take the y's, y2 minus y1, and put that on top of the fraction, and x2 minus x1 on bottom, that tells us the slope. So 7 minus 3, and 3 minus 1. So 7 minus 3 is 4, 3 minus 1 is 2. So a slope of 4 over 2, which equals 2. So that's what our slope is. And then what slope intercept form, which is the y equals mx plus b that we use up here, slope intercept. We have a point, we have 2 points actually, point slope. So let's write first in the point slope where it's y minus the y point times the slope times x minus the x point. Okay. If we solve this for y and make it y equals, that will convert it to slope intercept form. So let's solve this. Y minus 3 equals, first thing is parentheses, right? Order of operations. 2 times x minus 1 is 2x minus 2. Let's add 3. y equals 2x plus 1. Slope-intercept. Y equals 2x plus 1. That line will pass through both of those points. And we can graph that and check that out. Show that's true. So let's look at the graph of that real quick. Y equals 2x plus 1. And let's put those 2 points in our graph. 1, 3 and 3, 7. And let's label both of those. And look at our graph. Look there, the line goes right through it. I'm going to turn off these. Yeah, the line goes through both points. So we know that's correct because that's exactly what we're seeing. Next problem. Okay, problem number 21. What is the equation in point slope form this time? A point slope of the line passing through, well, we have 2 points. So we just need to find the slope, and then we can choose the equation in point slope form. So again, we subtract the y's, 11 minus 5, and subtract the x's, -2 minus 0. And we have to do them in the same order. Since I chose 11 as my first number, I have to choose the matching x as my first number. I can't swap those. I can't say 11 minus 5 and then 0 minus -2. I can't trade places. Whichever one's first is always first. So that 11 minus 5 is 6. -2 minus 0 is -2. So our slope is -3. 6 divided by -2. So this one's out because it has a +3 slope. So it's going to be one of these other ones. Right? So 5, 0. So it could be y minus 5 equals -3 times x minus 0, which would be just x. It would be the same thing as -3x, right? That could be one of them. I don't see that choice over here. So it's not that one. It must have used the other point. We could use any point on the line. So we can use either one of these points. So let's use this one. Y minus the y is 11, -3. X minus a -2 is the same thing as x plus 2, right? Because that's x minus -2. So here's the equation using the other point. -3, this one. See, they put the -2 just in case you missed that. Because remember, x minus -2 is going to change it to a positive. So this one's wrong because that should be a positive right there. Y minus 11, -3x plus 2. All right, number 22. Below are 2 different functions, f of x, which is right here, and g of x is on the graph. What can be determined about their slopes? Well, this is in slope-intercept, so the slope here is -1 because that's what it has right there in front of the x. That is the m, right? What's the slope here? Again, any place that it goes through a point. There's a place that goes through a point, goes through that point, that point, that point. Rise over 1. How much does it rise? Well, it goes down 2. How much does it? 1. So it's the same as the last one we had, -2. So this is the slope of -2. So which one, let's see, does f of x have a larger slope or g of x have a larger slope or the same? Well, it's not the same. And we can determine, so that's not right. So which one has a larger slope? Which one's bigger, -2 or -1? -1 is a larger number than -2. So f of x has the larger slope between the two of them. Okay, number 23. Below are 2 different functions, f of x and g of x. What can we determine about their y-intercepts, where it crosses the y-axis, the y-intercept? Okay, well, this is slope-intercept. So there's our intercept, -1. This one, where does this cross? Well, it depends on where the x is 0, right? If the x is 0, that means it's going to be right on the y-axis, right? Because this is where x is 0, and then 1, 2, 3. It's crossing where x is 0. So this looks like every time this goes up 2, this goes up 4, right? Every time that goes up 2. So if we go backwards 2, this would go backwards 4, and it would be -2, right? If we went backwards, 2 minus a 4, It's negative 2. Backwards here. 2 minus 2 is 0. So this is the y-intercept of g of x. So which one has a higher y-intercept? Again, negative 1 compared to negative 2. Negative 1 is higher. They're not the same. We can determine x is the higher one. F of x, pardon me. All right. 24. Below are two different functions, f of x and gx. What can we determine about their slopes? Now we have a word sentence and we have a table. So this table, when this goes up 2, each time 2, this is going up how much? This went up 16 from negative 4 to positive 12. And this went up 16. So if this goes up 16 every time this goes up 2, the change in the y's is 16. The change in the x's is 2. This has a slope of 8. Slope of 8 for g of x. What's the slope here? He runs the 400 meters in 50 seconds. 400 is how far he goes. This is how long it takes him. What is the slope of that? 400 divided by 50 is 8. They both have the same slope. For every 1 second, he runs 8 meters. Every 1 second, he runs 8 meters. In 50 seconds, he runs 400. Same slope. All right, number 25. Below are two different functions, f of x and g of x. What do we determine the y-intercepts once again? Okay, so here is, it's kind of hard to see that. It's right there. So the y-intercept is right here at 2. All right, so that's 2. The y-intercept here, well, we're going to have to figure out where that is. We know that as this goes up 2, and this goes up 4. So if we go backwards, but we only want to go backwards 1, so that's half of that. But here's the thing. It's already at 0. 0, 4, 8. If we go backwards, this is going to be some negative number, right? Some negative number. We really don't even have to calculate what it is because this is a positive 2. We know this is going to be bigger than any negative number. We can calculate it. It's going to be, since it's only half, we'll take half of that. It's going to be at negative 2. But we know that f of x is going to have the higher y-intercept because it's a positive number, and we knew this was going to be negative. So we don't have to necessarily know exactly on that one since we're just comparing. F of x has the higher y-intercept. All right, 2 problems left, and there are these graphs. This was on another page, so I cut it off and taped it on this page so we can look at them all at the same time. Brent has a model car collection. He was given 3 as a gift. So he started out with 3, right? 3 cars as a gift, and then 4 per year. 4 per year. So which represents his model car collection? So we know he started out with 3, so it has to have a y-intercept of 3. This one does not have a y. This has a y-intercept of 0. That's starting with 0 cars. This is starting with negative 3 cars. He's not going to start with negative 3 cars. So it has to be either this one or this one. These both have 3 as a beginning point. But we need 4 cars per year, so it should go up 4 every time it goes over 1. All right, it should go up 4. So if it starts at 3, when it goes to 1, it should go to 7. That should go up there. That can't be right. This one's at 3. Oh, that's at 7 after 1, and then it's at 11, and then it's at 15. We see that going up 4 cars every year. So this has to be the correct answer because it models what this says. 4 per year for every 1 year, because time is generally always down here. All right, one more. It's the same thing. Print on another page. All right, 3 months to live in his new house. After 3 months, he had 4 birds. 4 months later, he still had 4 birds. Which graph shows his total bird population? So months, again, time is generally always on the X. There's rare exceptions. But which of those shows at 3 months, it's equal to 4 birds, and at 4 months, it's equal to 4 birds? Let's see, months will be down here. So at 3, it should be right there, and then 4 should be right there. And that one is not it. This one will go to 3. He's at 4 birds. And at 4 is at 4 birds. This showing is just constant. He's always got 4 birds. That looks right. This one's a slope. This one says at 3, he's got -1 birds. He's got 0. Then he's got 1 bird, 2 bird, 3 bird, 4. That's not that. And this one starts out where he starts out with 4 birds. And then at 3 months, he's up to 7 birds. And at 4 months, he's up to 8 birds. So it's not that either. That is the one that's going to model that situation. So that's it. That is the practice test. If you struggle with any of those and still can't figure it out after watching this, email me. Check with me. Let me help you get that straightened out in your mind before you take the test. But otherwise, I hope you can do this really well and just killer on the test here this week. Let's do a great job and finish this unit strong.
Let's get out of here. Word to your multiples.
Math, baby. We're learning math, baby.